Okay, good morning, Krakow. This presentation is about a brewing support solution that I'm using to brew one complex type of beer called Eisbock. You can actually apply the same knowledge to a very famous Baltic porter, by example. As I'm living in a regular apartment in regular Soviet-era panel house, then brewing a complex beers can be challenging without pissing off wife and kids, as you may understand. And there are also another challenges that can be at least solved using technical tools. Wife and kids are not easy to solve using technical tools, believe me. In this matter, I cannot help you very much. Okay, here is the agenda. First, I briefly speak about the brewing process and then focus to Eisbock beer. Then we are getting really technical. I introduce you how I got to the solution I have and how I actually built it. And then in the end, I make a simple demo. I didn't took the device with me as I come on an airplane. I once had a device with me, and then I almost scared crap out from Frankfurt airport security personnel. I mean, there were suddenly those big Rambo-style guys in black uniforms and machine guns, and things started getting really out of my control. Okay, support materials for all those who want to use the same solution are here, and let's get to brewing. Okay, this picture is actually coming from a real brewery, but considering that home brewing process is almost the same, we can use it. Well, practically brewing starts with mashing. It means we are getting sugars out from malts. Then we are boiling hops in. We are cooling wort down, so it's not too hot for yeast. We are pitching in yeast, and then we let it ferment. In the end, sometimes we are maturing, sometimes not. This maturing phase, I think most of you who are knowing about Baltic porter brewing from grandfathers, it is also at international level called lagering. This presentation goes a step further. It's not about buying a truck, but how to raise the alcohol content of beer markedly. So, more about solution, although I'm focusing here more to monitoring freezing process. The same solution can also be used for all other steps in a brewing process where we want to measure temperatures, we want to monitor them. So it's not only about ice distilling. And if you are serious home brewers who are also living in Soviet-era panel house, then you actually need sometimes history data for complex beers, because it's very good before next batch to go back to previous one and check out how things worked out. What were the temperatures, or if there were any unexpected surprises. Okay, now what is Eisbock or Eisbock? The legend says that the beer was discovered or invented accidentally. It was cold night in one German brew house, and a brewery lad who was dragging barrels, the brew house was very tired and left some barrels for a morning. Night came freezing, and what was in barrels, that eventually froze, leaving just a little sip of liquid in the barrels. In the morning, brewmaster was mad, of course, and as a punishment he asked the poor brewery lad to drink what was left liquid in the barrels. When the poor lad took first sip of his punishment, wide smile came on his face, and as a generous guy he also shared this godly punishment with everybody standing around. And it is believed that this is how actually Eisbock was born. Using similar process is not allowed in every country in the world, so it's always good idea to check out if ice distilling or cold distilling is allowed, or at least if you have knowledge about where are those forests where you can bury a body, then you can go around the laws, of course. Now, here is a selection of some outstanding Eisbock beers. The second one, Aventinus Weizen Eisbock, is perhaps most popular and most easily available. I think for you it should be easy because you can just have a short car drive to Germany, load some of these excellent beers, and then come back. If you check alcohol content, then you see that it's pretty high. So this is not a beer you take a few six-packs for a football game, I have to warn you. Okay, you can do it, but then the morning of next day for you will start in the evening of next day. So here is a first test drive I made with my simple solution. I ran it using a battery bank because I didn't need any constant power supply. It was just to see how things work and if the whole Azure backend is also functioning like I expected it to function. And this is now the end result, snow-like sleet that you can shake so it gets clear like a snow sleet, and this way you can remove water from your beer. Practically you are brewing a double bock, and then after cold distilling it, you get Eisbock. You can do something similar with a Baltic Porter, and it jumps from 8 to 12 by example. Of course, you have to prepare your beer this way, so it doesn't have too much hops and so on. But these are brewing tricks you can easily find from internet. So, now what are the problems you face when doing something like this at home and in a small scale, and considering you don't have enough room for professional equipment? Well, one thing is that standard batch size in home brewing is 20 liters. And 20 liters of beer doesn't cool down very fast. It takes time, depending on weather, if you are doing it outside. Okay, if you are doing it on a balcony, then it's practically a dark chest of wonders. You know, house is giving some heat. Perhaps somebody left window open. If there is sun outside shining to your balcony, it may raise air temperature, and everything happening with a temperature of beer comes with a pretty big inertia. Of course, opening a bucket where beer is also problematic, because even though it's a cold winter, then wind may contaminate beer. It may introduce some dust, by example, that is not easy to remove, or worse yet, some stronger wild yeasts that later just ruin the taste of beer. So, and of course, when it's winter time and 3 days, I really don't want to sit like a watchdog next to barrel and wait while things start happening. Let's better do something cool. Well, in ideal world, I don't. I have some kind of solution that helps me to monitor what's going on, but not only inside a bucket, but also I wanted to know what's going on in a surrounding environment. So what's going on in a balcony? Is there some unexpected heat flow or not? There, I found some unexpected heat flows, because I just monitored the environment around the bucket. And also I want to know if something starts happening. In ideal world, it all should be in my pocket, and I don't waste too much time to getting this solution to work. So I don't have to code next weeks for nights, because I'm doing it, for myself, not for commercial reasons. So there must be some simple way. Then I came out with this drawing. Yes, it's original, because I was my own customer and I didn't ask the big load of UML diagrams and specifications and stuff like this. So I thought, well, let's take 2 temperature sensors. Let's get these connected to Raspberry Pi. It's small enough and cheap enough, so I probably don't have any issues with cabling, with the power supply, and so on. So somehow I managed to connect it to home network, and after this I get data to Azure, and let's see how to visualize it. There are different options. We can use perhaps some apps. We can use Power BI service, or maybe build something for mobile. So back in time, there was still at least some hope that Windows Phone will not be killed. So I consider it as one of possible options, as I had a device. So now a little bit of mathematics. I went through some materials about how to start estimating when beer gets to temperature, when it starts turning to sleet. Simplest and most robust thing I found was Newton's law of cooling. Okay, so in big part, actually the cooling process is going like shown here on a diagram. But the closer to cooling to freezing temperature, the more this Newton's law starts lying, actually. But it is still accurate enough to find out if we have hours of time until we have to pay attention to bucket or not. So from this equation, actually, it is possible to get all the estimates we need with some tricking. So now, how I got to a IoT solution. So I knew that it is possible to do it with a Raspberry Pi. There are some simple components available, so it took just few euros to get those thermal sensors, resistors, and everything else. Of course, I had also a friend who is working in some kind of industry automation company. He told me about these components, that if you have never before put something like this together, then probably you burn your fingers. So let me connect everything at my work. I have spatial devices. So I said, okay, why not? Now Actually, this is here is a scheme I used when in the planning phase. My electronic friend said, "Okay, this is easy to do," and the picture here is showing the end result. So we decided to use this ugly plastic box to keep electronic connections just isolated from whatever is the weather outside. So if it's in February, then we have a sea nearby. If storm is coming from a sea, then we have a piles of snow on balcony. So I don't want it to ruin my holy mission to get the delicious beer. Now, with everything connected, I focused now to how to get things work. Well, it turned out it's actually pretty simple. So on Windows, for Windows IoT Core, we have a special projects on Visual Studio. So actually, we can build their so-called headless service that doesn't need any user interface. It is started up and run in the background. So in this service, I can easily make a connection to Azure IoT Hub. I talk about it soon, and then start reading the sensors. I also found also a ready-made library to read temperatures, and there I got immediately my first lesson. I just wanted to find out how frequently I can read temperatures. So I saw that okay, this IoT thing is giving errors when I try to read after every 2 seconds. Okay, but let's try after half a second. Then Raspberry crashed completely. I mean, it blacked out completely. So I had to restart it. Well, as it turns out, then taking a sensor reading may also take a little time. So you have to find out approximately how long it takes. So you don't read faster, because otherwise it's just a chaos. You don't control anymore. I found a library called Rins and one wire. This library is excellent for these temperature sensors I have. Okay, let's take the code here. Okay, so practically what I'm doing here is I'm creating a new one-wire handler, and I ask it for this kind of sensors. So it has support for it. If you are not electronic guys, then I suggest just take sensors that are already supported by some pieces of software. Otherwise, you will find yourself fighting with specifications not very familiar for you, where you are sending byte arrays to somewhere, reading them back, and so on. It's way more work than getting some ready-made library work, especially if cold weathers are coming and you are already in a hurry, like I was. Otherwise, perhaps I would have taken an electronics book and sat down and found out how things really work. So now, if I have devices, then I can read temperatures and return these back to my startup task. And here after making some calculations, I send these calculations and measurements all just to Azure IoT Hub. So in its core, actually startup tasks are very simple. They have a run method. If you are using anything asynchronous, then you also actually need to take care of deferring. But in big part, this is how I got things work. I made a timer that is triggered after every 20 seconds, and then I was just checking if the process is closing or not, and held my background task alive this way. Okay, let's get back to slides. So practically, this is how things work in IoT device level. My newer solution is a little bit better because that is available also on GitHub. It's a little bit better because there I implemented one thing a little differently. First, it is not dependent on Azure services so much, but you can host things on Azure too. It's not a problem. And it is performing actually different calculations, not on IoT device, but in the backend. So the IoT device is just reading, reporting, and so on. So this way it works most stable. Currently here I'm showing you this so-called big model because as I told, I was in hurry because it was getting very cold outside already. I didn't had much time to build a nice web interface and so on. I just wanted to get the data out from device and the data visualized and be available in my pocket. So actually, if you have a free Azure credit, month-based, then you can use this big model too, but otherwise better go with something a little bit smaller. So Azure IoT Hub is practically Azure Event Hub, but it is built up a little differently. It is built to scale at massive levels. So this is we can take some modern iron concrete house. If we want to cover it with all kind of measurements, we need around 20,000 sensors per big house. So, and now consider these sensors shooting data out after every, for example, 15 seconds. And if you are a real estate developer, then perhaps you have 10 big houses like this. So a good thing about Azure IoT Hub, although it is for now way more complex and way bigger service than it was before when I started with my own solution, there is a free scaling tire available. So if you are not taking reading after every few seconds, then free scale tire is more than enough for home brewing. And if you ask about how to get communication up with IoT Hub, then Microsoft provides you with NuGet packages for free. So it's just up to you to add it to your solution and use it. So next question I had actually was, now when I get data to IoT Hub, then what's next? So it's somewhere there, but how I get it now to somewhere where I can easily visualize it. Okay, then I found a thing you don't want to very much use at home scenarios, stream analytics. It's practically a service to process real-time streams of data. So you have input sources where data is coming in, processing queries or functions, and then you have sources where processed data is sent. Stream analytics is actually cool, I can say, but it is not cheap service. So, but I found it again to be actually a pretty good service for visualizing data because it is able to read from IoT Hub and send data out to SQL database, and in my case also to Power BI. So now I was in a point where I can already almost touch data visualization. Okay, so first thing I looked was a Power BI. There is a free option available for push data. It means that data is pushed in to your Power BI account from some external source. If I'm correct, it was 2 gigabytes of data that is free in a push model. So you don't pay for anything. Good thing is it has web interface. It's available for mobile. Also Android and iPhone should be supported. It has also a desktop application, and it's pretty easy to build up nice user interfaces on Power BI. It is a little bit annoying sometimes. It can be a little bit laggy. It can be a little bit confusing sometimes how it works, but overall, still it's a good tool to get the freezing process to your pocket. If you have always laptop with you, everything is happening in your local area network, by example, then of course you can also go with a simple Excel sheet. I mean, you can easily make remote desktop connection to your home machine, check out what's going on from Excel, and act based on what you see. In Excel, you can also make connection to SQL Server. You can tell Excel to refresh data, by example, after every 30 seconds. So considering that all these temperature changes doesn't happen rapidly, probably you don't go and check this Excel sheet after every 30 seconds. I think it's more like, okay, now it's morning, let's check out what's going on. Next time you perhaps check out what's going on at noon or afternoon. So you can be kind of sure that what you see there is a pretty fresh data, and of course it doesn't come with any additional costs as a Power BI may come if you want to make there something bigger or cooler. So I also for some test drives I tried out Excel, and actually a primitive Excel table with a chart like this, it also works out very well. It actually all depends on how lazy you are. I'm extremely lazy, and then I thought, okay, I don't have always laptop with me, especially when it's very cold outside. I don't want to drag with me a backpack, and perhaps I can write a simple UWP application, something that I can install on my Windows phone. I can just run it, and it will how I say sneak around all these SQL database and stream analytics stuff, and connect straight to IoT Hub and start reading data, just in case if things are happening fast for some reason. So although for now Windows Phone is almost killed, then this UWP thing actually lives, and and what's built on UWP can be also taken to, by example, to iOS and Android devices. And of course, you can also build a monitoring solution where you have, let's say, some screen, and you are using Windows IoT Core and Raspberry Pi to visualize freezing process practically the same way. So this UWP stuff is not completely useless, although Windows Phone is for now almost dead and gone. Now let's see how things finally work. So here I have a stream analytics service. So I run it because it takes it a little bit time to get started. So and let's take a look at QArray. Actually, this stream analytics service, the QArray that is processing data, is very similar to what we have seen when working with SQL Server. There is one little trick. As it is processing real-time data, it means that it's not anymore a table that starts with a row number 1 and ends with some row number n, but it's a stream. Data is just flowing in. So now if we want to do something with this data, we want to process it, then you can see in the end of the first QArray something called tumbling window. It means that all the processing happens usually over some period of time. There are some other options, but here the period of time is enough. For example, if you have IoT devices where you can control how much or how often it is sending data, then what you can do, you can always use a stream analytics to aggregate data. Like I have done here, finding average temperature of beer and average ambient temperature. Here I'm using it for demo purposes over a 20 seconds time window. When I'm really ice distilling my Eisbock, then usually I let it go over a 15 minutes time window. It's enough for me, and it doesn't grow my poor SQL Server database too big. As we heard from previous presentation, then things on Azure have a price tag, and I don't want too much data that is duplicating itself. I mean, things are not happening very fast in a balcony when 20 liters of beer is cooling. Okay, now here we can see also when I run some code and data starts moving, then Stream Analytics is showing us also some real-time data here, so we can be aware that everything is okay, and same way we can also check out what is doing our IoT hub. It is showing how many messages our devices have sent. Device to cloud message means the message that device is reporting to IoT Hub. IoT Hub supports also messages where some service is giving commands to devices, by example, or notifying devices of something. So usually when using those dummy temperature sensors, we don't need to guide them anyhow. So here now is Power BI. I have here one chart and one table. It all looks pretty lifeless here. I can try to let in some pointless data to it, so it shows something. But let's say if it. Okay, so some test data. We are taking older data, so this data will be generated by emulator. I also run Power BI application. Wow. Now it wants to sign in. Yes, of course. So this is now a desktop or Windows Store application. This is something you can also run on your Windows 10 machine, by example. It practically has same things available that this web interface. Okay, let it synchronize a little bit. Oh, okay. Now we are talking about beer. That's great. Okay, and I also run UWP application. So this is the same one that is now sneaking around stream analytics and stuff. I can actually use it also in cases where I don't want to save any data. I don't run stream analytics. I don't want data to get anywhere. I just want real-time data. So this is also okay for brave men who already know how to control all this freezing stuff. But it is convenient as this way I get always the ongoing data that is not yet processed. Remember that stream analytics is a service that is not cheap one to run. So if you can avoid it for home scenario, then well, you have less worries in the end of month when Microsoft is sending out the bill. Okay, and now I run emulator that starts sending readings to IoT hub. So let's pray that internet connection works well. I'm sure people are praying somewhere nearby, many churches around. So, okay, here we can see already it is reading IoT hub. So as soon as something is sent to IoT hub, this blue line is changing a little bit. Now let's see what is doing our Power BI. Okay, I tell it to save, and let's go to reading view. Sometimes there are delays when Power BI is doing something, especially if you change something. So okay, it is reading data. It's slow, and now let's keep eye on this guy. this line is okay. So we are slowly getting better. Of course, it is possible to design these Power BI reports to look better, but it's a bunch of additional work. It's not often it's not so convenient as Excel. You are just dragging a table, you are just dragging a chart, say, okay, data is here, now show me. And it looks almost nice. Okay, Power BI is a tool that is used mostly by professionals who know how to make all this cosmetics. Okay, let's refresh it. Okay, this one here is getting more and more to shape. This one here is showing something totally weird now. Okay, I apply a filter. Let's see what it's doing then. So and again on Power BI things can be slow. So but this one is moving on. So it is slowly this blue line is getting smoother and smoother. I'm not sure if we have currently slow internet connection or what's going on, but okay. Yeah, but emulator is shooting its sensor readings to IoT hub. So these messages are actually very small by size. It's even when when at home kids are every kid is watching its own video from YouTube. And they manage to overload home network, then these messages usually go through because they're small and they don't need much resources. Okay. So let's see if okay, Power BI is still in action. I think there's something with internet connection. Now I switch back to slides, and as I've asked sometimes but what real data looks like. Okay, this is a lagering phase of one of my Czech Pilsners. It is a newer application with a web interface. So red line is beer temperature when it is after fermenting. When I took a bucket and put it to a cool room. Blue one is air temperature, and green one is actually read from local weather service. So as you see, then at some point in a lagering phase, beer and air temperature are almost the same. Beer one is stable, air one is jumping around. Now, when ice distilling, my suggestion is to do it like Germans. Keep your bucket open, but cover it with some thick cloth, bunch of cloth, so air doesn't draw in any dust or something. But you have to keep heat exchange as free as possible, because otherwise this is what happens. Now take a look what is air doing. Air is getting meanwhile to minus 6, almost -7, and beer temperature is constant. So if you leave bucket on, then suddenly cooling of beer gets extremely slow and the sleet is not forming. So But if you have if you have a bucket open and covered with a thick and strong cloth, then the freezing goes normally. In this case, practically this red line will approximately follow the blue one. Also, what you see here is that changes in temperature during day and night can be pretty high. So it's possible that you start with ice distilling. Weather station is telling you, okay, guys, it is next week. It will be cold. It will be up to, let's say, -10. You are clapping your hands. Okay, now it's time. And then it turns out that you get perhaps 2 cold nights. You have to wait for 5 days when your beer starts to form sleet. So you can start removing water. So this waiting time is the most annoying, and this is actually what motivated me to build up this solution, because otherwise I don't know what's going on inside a bucket. I have to constantly open it or wait nearby. Okay, now it's kind of cold. Okay, what is my beer doing? So, but with this solution, I made my life actually way easier than I first thought. Okay, well, here are also links to some places where you can find out more information. This GitHub project, currently I have to port it over to latest .NET Core and upgrade also other NuGet packages, but in all other means it's practically ready for coming winter. It's all open source. I don't earn any money on it, and if you find that it is something useful, then feel free to use it or be part of a discussion or come out with some great ideas. This is almost the end by me. Let's see meanwhile for how this chart is going. Okay, so soon beer is getting close to ambient temperature, and it's time to close the demo. I also make one check to PowerPoint, but Power BI, but seems like it's still doing something mysterious. Okay, but anyway, feel free to ask me questions about the solution and the tricks, and of course, thank you for coming to listen to me.